These are the notes for September 2nd and September 7th. We're transforming sine and cosine. These guided notes are continued from the last class, so if you don't have these, you can access these by clicking on the link that is associated with August 31st and September 1st. But here we have the parent function for sine and cosine. Now we're going to try and transform it. And so what we have here is sine of x plus 3. In class, what we decided is that we can utilize some of the same order pair or some same x values that we used in the past. So like 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we're going to plug those values into our function, get our output in order pairs, and then see what's happening between sine and our transform function. So I'm going to do the first two, and then I'll just add the points. So we plug 0 into our function here that we had g of x. 0, plug it in for x. Sine of 0, if you go to your unit circle, or if you want to look at the graph of sine from previous class, sine of 0 is going to be 0, so we get 0 plus 3, which is 3. And so what we input into our function was 0, what we got was 3, and so that's an order pair that we can use. Similar thing if we do pi over 2. If you look at the graph or if you go to the unit circle, either way is fine. But what we can say is sine over 2 is 1, plus 3 is 4. And so we get pi over 2, 4. I'm just going to do this. And we can do a similar thing for pi, 3 pi over 2, and 2 pi. If I were you, I would pause it, see if you can get the same things. I'm just going to do the order pairs here, though. But you might want to pause it, see if you can get these order pairs and know where they're coming from. Pi and 3. 3 pi over 2 and 2. And 2 pi and 0. So these are order pairs we will use to graph sine of x plus 3. So let's do that. So I'm going to scale my axis now, my axes, 2 pi, let's call this pi, pi over 2, 3 pi over 2, negative 2 pi, negative pi, negative 3 pi over 2, and negative pi over 2. And then we can look at our values here. Our lowest value here was at 0. Oh, that is actually wrong though, because sine of 2 pi is 0, but then I have to add 3. So if I add the 3, that would be 3. Our lowest value here is 2, and our highest is 4. So let's go up to 4 on our x-axis. So 1, 2, 3, 4, and I'm just for symmetry's sake, negative 1, negative 2, negative 3, and negative 4. So we have our ordered pairs, we get our ordered pairs, we can scale our axes, y-axis, x-axis. Now what we're going to do is, I'm going to go ahead and graph the parent function. So our parent function is sine of x. You might need to refer back to your old notes, or go to the previous video before this. But here's our parent function. I'm just going to do it like that. With a dotted line, that's the parent function for sine of x. And then we're going to start plotting these points. So 0, 3, right there. Pi over 2, 4. Pi and 3. 3 pi over 2 and 2. And 2 pi and 3. And then we can go ahead and draw the smooth curve that goes through those points. Okay. And that's our new function. So here's our dotted line. This is the parent function for sine of x. This is our new function. And so what we talked about in class is, if you look from our parent function to our new function, all of the points are shifted up. And more specifically, we went from, if you were talking about the y-axis, we shifted it up 3 units, 3 units, 3 units. Everything is shifted up 3. And that 3, so we're looking at the graph here, comes from here, right there. So in general, we said if we have, let's say, cosine of x minus 7, then we can draw the parent function and then shift it down 7. Okay? So that's our function. Now, I would encourage you to talk about domain, range, amplitude, all of those things. For right now, I'm going to skip that just for time's sake. But I would encourage you to talk about that if you have questions about amplitude, period, domain, range, those things. You can come talk to me. But in general, if we add outside of our parent function, it's going to shift it up that many units. If we subtract outside of our parent function, it's going to shift it down that many units. Okay. So let's do something similar here. I started with negative 2 pi here. So we have something added inside our parent function, inside the parentheses. I'm going to go ahead and scale it. Negative 3 pi over 2, negative pi over 2, and 0. So for example, if we do sine of negative 3 pi over 2 plus pi, you'd have to add the fractions, and that would give you negative pi over 2. If you need help with that, you need to come to ask me. I'm going to do that right now. And sine of negative pi over 2 is going to be negative 1. And so our order pair is negative 3 pi over 2, negative 1. We could do a similar thing for the rest of them. Negative 2 pi. If I plug this in, negative 2 pi plus pi is negative pi. Sine of negative pi is 0. Similar thing for negative pi. Negative pi over 2 would be 1. And 0, 0. Okay. So similar thing as we did on the last one. I'm going to, just so I can keep that point there, negative 2 pi, negative pi, 3 pi over 2. I'll keep the scale the same. So then we scale our axes. If you look here, our lowest point is negative 1 and our highest point is 1. So I'm just going to keep negative 1 and 1. Okay, so we get our order pairs. I would pause it, check, make sure you see where these order pairs are coming from. And then what we can do is go ahead and draw the parent function. It's still sine, so our parent function still looks like this. We go up to 1 at pi over 2, pi and 0, 3 pi over 2 and negative 1, 2 pi and 0, and then down. Alright. So this is the parent function for sine. Again, you need to refer back to your notes or look at the previous videos to make sure you understand what the parent function for sine looks like. And now let's go ahead and graph these points. Negative 2 pi 0, negative 3 pi over 2, and negative 1. Negative pi and 0, negative pi over 2 and 1, 0, 0. So this function will look like this. Okay. So in class we had a good discussion about what's happening here. What happened from our parent function, the dotted line, to the solid line, our actual function. And some people said it was a reflection, but we're looking at how we shifted in terms of pi. And what's happening here is this point, these points, every point, if this is our parent function here, is being shifted to the left. And if I'm here at pi and I shift to the left and get to 0, I'm shifting to the left pi units. So from pi over 2, if I shift to the left, I'm subtracting pi. It's going to be at negative pi over 2. Okay, this point here shifted to the left, pi. All of our points are being shifted to the left, pi. And so what we said is if we shift inside of our function, so it's f of x, sine of x plus 6, that shifts it to the left 6 units. If it was cosine of x minus 7, that shifts the function to the right 7 units. This one is a little counterintuitive. If you add, you think you move to the right, but really you're moving to the left. Similar thing if you're subtracting, and that's inside of our function. Hopefully this is similar to what you've learned in Algebra 2. We need to know these key differences. If it's outside of our function, if we're adding, we move up. If we subtract, we move down. If it's inside of our function, we add, we move left, subtract, we move right. On the next video, we'll go through describing a few different functions, and then we might even graph a few. So go to the next video to get more practice with this.